So today we will discuss about ASM, because Oracle RAC is depend on grid infrastructure, ASM, and RAC itself. So this is the combination of three technologies which we used in RAC. So that's why I'm going one by one as a architecture level. So we did grid infrastructure, we did RAC, now ASM architecture we will discuss today, and it is very long a concept actually. So I will try to finish today. If it is not possible, then I will take another session. So this is Oracle ASM. So the left side figure, which is basically the old storage system, and this is new. So this area is basically uh, similar to this ASM and operating system. So earlier we use operating system, then logical volume manager, which is a part of OS technology, and then file system. So Oracle introduced ASM in 10G, and that replace LVM and file system. So this is the ASM, but actually if anybody is asking what is ASM, so you can say that Oracle ASM is a volume manager and a file system for Oracle database files that supports single instance Oracle database as well as Oracle multiple instance, means Oracle RAC. Clear configuration. So Oracle ASM is Oracle recommended storage management solutions. Okay, and that basically provides an alternative solutions for your conventional method, volume manager, and file system and raw devices. So this is the difference between conventional method and ASM. Clear? And
Yes.
why we are doing this? Because combining volume management function with a file system basically allows a level of integration and efficiency that you cannot get it from any other method. So ASM is able to avoid the overhead associated with the conventional file system and achieve native raw disk performance for Oracle data files and other file types which is supported by ASM. So that's why ASM is better than logical volume manager and file system, because that creates overhead, but ASM will not create overhead. So ASM is basically operate effectively in both cluster and non-cluster environment, means single instance and multiple instance. So Oracle ASM file can coexist with other storage management option like raw disk by the and third-party file system. So this feature also give the advantage of using Oracle ASM in pre-existing environment. Suppose in your old existing environment you have these type of features, so you can use ASM also. So there is no problem using ASM in existing architecture. Clear? Any questions? Okay.
This
No, we are
logical one,
fine.
is it the
Okay.
data store? Is it equal to data store or what, Mr. Ahmad?
Your voice is very slow, Rahman.
I was asking that this logical volume manager, is it a data store or what?
Logical volume LVM basically operating system concept, where we have uh, first we create the LVM, then in that we create the file system. So that is, suppose we are using Red Hat Linux, so in that this feature you will get it. So in that, if suppose you are getting any space issue, So you can transfer space from other LVM to another LVM, like that. This concept is uh, work actually.
Okay, sir.
Okay, so the next slide is we have another feature which is called as ASM CloudFS, which comes new, and ACFS, which is already there. So ASM manage Oracle database file. So Oracle Cloud File System is designed to help organizations which deploying their applications, database, and storage in private cloud. So ASM Cloud FS work for private cloud. It delivers basically a cloud infrastructure that provides network access, rapid elasticity, and provisioning for pooled storage resources that are the key requirement for cloud computing customers, cloud computing, and customer can use Oracle Cloud FS to manage and store all database file types, including general files. So Oracle Cloud FS includes Oracle ACFS and Oracle ADVM, that is Oracle ASM Dynamic Volume Manager. So if you see this, this is ADVM, and this is ACFS, and instead of that, you have CloudFS also, that I'm talking about. Okay, so Oracle ACFS is a multi-platform, scalable file system and storage management technology that basically gives an advantage to Oracle ASM to support all customer files, right? ASM, if you are using, that will support to store the database file. If you are using ACFS, it will manage other files like Excel file, text file, and photo files, like that. Okay, so that is the work of ACFS. So Oracle ACFS supports these type of files. Okay, and like trace file, alert log files, application report, B files, and configuration files. So other support files are also video, audio, text, images, engineering, drawings, and other journal purpose. Okay, so without ACFS, that is not possible. And if you are using cloud, then you will use ASM Cloud FS. Clear?
Sir.
So you can say that Oracle ACFS file system communicate with Oracle ASM and is configured with Oracle ASM storage. As you can see in the figure, this is ACFS and this is ASM. So application connected to ACFS, then ACFS to ASM. Okay, and also application can use third-party FS file system and ASM. Okay, or ADVM and Oracle ASM files for Oracle database. So this is the way you can configure ASM combinedly. So you can use multiple things for that. So Oracle ACFS dynamic file system means which you can resize, and it provides maximum performance through direct access to Oracle ASM disk group storage, and it balanced distribution of Oracle ASFS across all your Oracle ASM disk group. So that will increase your IO parallelism and data reliability through Oracle ASM means mirroring protection mechanism, right? So Oracle ACFS is a good option for Oracle clusterware technology, which directly basically participate directly in clusterware cluster membership, stale transitions, and in Oracle clusterware, resource-based high availability management. So the Oracle installation, configuration, verification, and management tools have been updated to support Oracle ACFS. So this is ASM Cloud FS and ACFS. I hope it is clear. I'm just giving overview. In detail, we will discuss later on. I'm just starting the ASM, so that's why every component I'm touching in a shorter way, because in one day I can't finish ASM, because ASM has 1000 pages book. Okay, so that you need to read it to understand the ASM. Now, ASM features and benefit, that is very important. So first thing is that it strives file rather than logical volumes. So what does it mean? Can anyone tell me?
It's a disk group.
Uh, Actually, striping means it divides the file and equally distribute to the disk.
Okay. Anyone else? Actually, ASM provides striping and mirroring, right? So ASM divides a file into pieces and spread them evenly across all the disks, right? So suppose you had 4 disks, so it will stripe the data file and it will distribute equally to all the disks. Clear? And how it will do that? ASM uses an index technique to track the placement of each piece, and traditional striping techniques use mathematical function to stripe complete logical volumes. So please remember that. And ASM is unique in that it applies mirroring on a file basis rather than on a volume basis. So therefore, the same disk group can contain a combination of files protected by mirroring or not protected at all. Okay, so that is basically stripes files rather than logical volumes, provides redundancy on a file basis, enable online disk configuration and dynamic rebalancing, significantly reduce the time synchronize a transition failure by tracking changes while the disk is offline. It provides adjustable rebalancing speed, is cluster aware, and it supports reading from mirroring copy instead of primary copy for extended clusters, is automatically installed as a part of grid infrastructure. So when your storage capacity changes, ASM does not restripe all the data. Is it true or is it false? Tell me. This is interview question. Any idea? Yes, correct. ASM does not restripe all the data, but in an online operations, ASM moves data proportional to the amount of storage added or removed to evenly redistributed the files and maintain a balanced IO load across the disk. Okay, so you can adjust the speed of rebalance operation to increase or decrease the speed and adjust the impact on the IO subsystem. So this capacity also enable fast resynchronization of disk that may suffer a transition failure. Okay.
Dear Ahmad, is it not related with the RPM of the disks?
No, that will become later on. I'm talking about ASM feature. I'm not talking about the ASM disk feature. If you are using fast disk, then you will get better benefit in ASM storage option, because ASM is a kind of software which installed when you installed grid software, right? So if you have fast disk, then it will be better. If you have slow disk, then you will get less benefit instead of using ASM. So ASM basically uh, uh, rethink time failure of an online disk. Basically, ASM moves data proportionally to the amount of storage added or removed. So it will evenly redistribute the file and maintain a balanced IO load across the disk, right? So you can rebalance, you can adjust the speed of rebalance operation to increase or decrease the speed and adjust the impact on the IO subsystem. Okay, so that comes disk speed actually. So this capability basically enable fast resynchronization of disk. So ASM support all Oracle database file types. It supports RAC and eliminates the need to cluster logical volume manager or a cluster file system. And if you are using extended cluster, you can set a preferred read copy. So ASM is included in the grid infrastructure installation, as I said, and it is available for both enterprise edition and standard edition. So Jitendra, did you get it?
Yes.
Now see, this is ASM instance design. This is the first design by that you can configure your database. So here you can see that you have three databases, A, B, C. It means it is a single instance or non-clustered, right? And in that you are using one ASM instance, which is connecting to all databases. So this type of configuration is called non-cluster ASM and Oracle databases. Okay, so all the bottom of the picture, you see that there are two this group of that ASM instance, which used to provide space for the database. So in this environment, a single host machine contains the ASM instance along with each of the three databases instance. So each databases can store the files in both this group or only a single disk group if desired. So ASM instance basically manage the metadata and provides space allocation for the ASM files that are created by each database. So this is the work of ASM instance. So when a database instance creates or open an ASM file, it communicate those requests to the ASM instance. In response, the ASM instance provides file extent map information to the database instance. This is important line. And the ASM instance does not process actual file IO. So this design is useful for storage consolidation. So we had two questions here. Uh, the first question is what? What ASM instance does? So you can say that ASM instance does basically manage the metadata and provide space allocation for the ASM file. Okay. So then another question is that the ASM instance, how identify, how tell the ASM instance, how communicate with the database instance where your disk is there. So it will provide the extent map information to the database instance. Then database instance get to know that, okay, here I need to write the data, or here from here I need to read the data, like that. So this extent map is a key factor between ASM instance and database instance. Clear, guys? And maybe I can ask, will ASM instance provide the actual file IO? So you can say that no, it will not process actual file IO. It will does by the database instance actually. Clear? Now this figure. Here you can see that you had ASM instance 1, ASM instance 2, ASM instance 3, and you have database A instance 1, instance 2, database B instance 1, database B instance 2. So here you had cluster ASM also, and you had cluster database also. Got it? And you had 3 disk group, and you had 2 disk, 3 disk in 1 disk group and 2 disk in another disk group. And one ASM instance is reside in one server, one ASM instance is reside in another server, ASM instance is another server. But for database A instance 1, database B, database A instance 2, they are using separate instances. But for RAC database B, they are using only one instance, right? So it means that is non-cluster. So Oracle database B is using non-clustered ASM instance. Clear? But itself they are clustered. Clear? So this way also you can configure ASM. Clear?
So Ahmed, you mean to say that the disk groups can be shared across servers
All
and
the databases.
cluster?
Yes, yes, yes. Because ASM instance will tell that where is your disk, where you have to write, where from where you have to read. That provides the extent map information to database A and database B via instance 1, instance 2, and instance 3. ASM instance I'm talking about.
Yeah, my question was the ASM disk groups. It can share the multiple databases, isn't it?
Yes, figure is showing this. So you see, you can use ASM cluster. We called as ASM cluster for Oracle RAC database environment, where ASM provides a clustered pool of storage. If a standard ASM is configured, then there is one ASM instance for each node that can provide space management for multiple RAC or single instance database in that cluster. Okay, and it is not necessary for each node that is hosting a database instance to also host an ASM instance. So in the figure you see that 2 RAC database are there. Oracle RAC database A has instance on the first 2 node, and Oracle RAC database B has instances in other 2 nodes, and they represent 2 distinct RAC databases. So the ASM instance coordinate with each other when provisioning disk space from the 2 disk group. Okay, so in this diagram, ASM provide storage consolidation and RAC provides database consolidation. Okay, so this is the mixture of both storage consolidation also and database consolidation also, so that you can configure. If you see this diagram, third diagram, so see that what is the difference in that. You had cluster ASM Cluster ASM means one ASM instance is supporting two databases, and another ASM instance is supported another two databases, right? And you can store two databases on one server, and you can store one database instance two is one server, one database instance one on one server. Let me take a pen. See that here two databases is using instance one and store here, and here instance B is using this and store here, and this database instance is using this and store here, and also this store here. Okay.
Yeah, it's a bit clear, but I was talking about the disk group. For example, disk group A is being shared by ASM1 and ASM2. So same disk group
Both,
name will appear in.
yes, see this arrow, both this group A and this group B is giving this server, and this group B is giving support to this server also, but this server is separate server. Okay. So let me elaborate this. Give me
No,
2
it's
minutes.
clear. It's clear. It's clear, dear. It's clear.
So here you see that this group A and this group B. So A shared storage pool is achieved basically using Oracle clusterware. In this design, clustered and non-clustered database environment are used on each of the three nodes. Okay. And this design is basically useful is in grid environment where any instance can be moved to any database server node, and multiple instance can reside on any node. So in this example, C instance 1 is a client of ASM instance 2, which has incorporated another ASM, that is Flex ASM. So the mode is basically based on standard ASM. So I will not talk about the Flex ASM, that I will not cover actually. So this is the configuration, and now come to what are the ASM components. So what are the ASM components you required? So you are required to create two directories for installation of the Oracle software binaries. So the Oracle base and Oracle home directories. Okay, so that is required. So Oracle under base is basically a top level directory, and Oracle home is used to identify the top level directory of the grid infrastructure software. So we can use Oracle base for all Oracle product, and we can use Oracle home location for all Oracle product, and do not place grid home below Oracle base. Okay, so that is condition. So suppose we
Ahmad,
follow.
sorry.
Yeah.
Those two databases, the one instance, one of two database, they have to be on a single box, right? On a single server. They cannot be on multiple. Like ASM instance.
For one databases, two databases of same version will installed in same directory.
Yeah,
But
I'm
on
talking
one
of like the
server
box.
you can create multiple databases version. You can install multiple versions. So that's why it is differentiate after product U01 app Oracle product, then 11.2, then 12.2, then 18C, then 19C, like that.
So my no, I'll ask you a different way. The ASM
You are
instance
asking
is
previous slide. You are asking previous slides question, right?
yes. Like here the DBA, DBB instance one, they
Uh,
have to be on the same box, right?
just us again.
Same server.
Yes.
Okay. Yeah, I got it.
And this is this, and this is reside here. So this instance is using this also, and simultaneously it is using this also. So that combination also work. Okay.
Okay. So it in the second case, in the D instance 2, although it is using the ASM from another server, still like the data files, everything will be on another server for
Yes.
correct?
Yes.
Okay.
Yes.
Yeah.
Yes.
Thank you.
So ASM component. So I'm talking about the software. So why I am telling this? Because when we install the database software, on that time we create the directory. So we follow OFA, or optimal flexible architecture, which is guideline recommended by the Oracle. So you will do this like U01 app and software owner. Like this, you will choose the path. You say U01. Sorry, my writing is this very pathetic. App, and suppose my owner is Oracle. So I will give Oracle U01 app Oracle. If my owner is grid, then I will say U01 app grid. So this is OFA actually. And if you use a single owner installation for both database and grid, and then owner is grid. If you use separate owner for database and grid infrastructure software, then create the operating system environment variable, that is Oracle base, to locate the Oracle base directory. If you set the environment variable Oracle base for the grid user, so Oracle Universal Installer creates Oracle inventory directory in Oracle base, and then slash dot dot Ora inventory path. So Oracle inventory directory, that is Ora inventory, stores an inventory of all software installed on the system. I hope that you know that. So the Oracle home directory is the directory where you choose to install the software for a particular Oracle product. So you must install different Oracle product or different releases of the same Oracle product in separate Oracle home directory. So that is OFA guideline. So like U01 app 12.1 O grid, and you can say U01 app 18C slash grid, like that you can create it. Got it? And create the operating system environment variable Oracle home to locate the Oracle home directory for the grid infrastructure software. So I hope that is clear to everyone.
Yes, yes.
Okay, the another component of ASM is ASM instance. That is very important. So if you see that ASM instance is similar to your Oracle database instance, because Oracle database instance also has SGA, and Oracle database instance also has processes. But the difference is what? Tell me, what is the one line difference between a database instance and ASM instance? Interview question.
Memory
One
is
line answer.
small. Memory is smaller.
In ASM instance, we don't have a
Okay.
data files.
Okay.
No, sir.
In database instance also have data file.
Sorry.
No, no,
It
it's
has
okay.
only
Also,
memory.
don't say sorry. We
Okay,
are
database.
equally actually. Don't say sorry.
So it has carry only memory to connect to database.
That ASM database instance also has the memory and mount the database.
The memory of
Okay,
ASM instance is smaller than the database instance, and it
yes,
can be
correct,
only
absolutely
more.
correct. Absolutely correct. So Avinash answer is to the mark, that ASM instance memory, or you can say ASM SGA is less than database SGA, and ASM ASGA has shared pool, large pool, ASM cache, free memory. So these are the four component, and also ASM processes we have RBEL, ARBN, GMON, ONN, and PZ9N, MARC, okay, and other miscellaneous processes. So every time ASM or a database is started, SGA, basically shared memory, is allocated and ASM background process are started. But because ASM performance fewer tasks than a database, so ASM SGA is much smaller than a database SGA. So that is the reason ASM is smaller, and database SGA is bigger. Clear? And the combination of background process and the SGA is called an Oracle ASM. So the instance represent basically CPU and RAM components of a running ASM environment. So the SGA in ASM instance is different in memory allocation and usage that the SGA in a database instance. So here we have shared pool. So that is used for metadata information, and large pool that is used for parallel information, parallel operations. ASM cache is used for reading and writing blocks during rebalance operations. Please remember that. And free memory, basically unallocated memory, which is available, and if any memory is required, that will allocate from free memory. And the minimum recommended amount of memory for ASM instance is another question. Tell me, type it. Whenever I ask any questions, please type the answer in chat room at least. On that time, please don't speak. It's my humble request. So what is the minimum ASM instance memory requirement? Anybody knows that minimum value? 512 MB, okay. 8 MB, okay. We are 24 people and only 3 answer I'm getting in the chat room. One GB is also fine.
I think in some versions it will vary like 512 or 1 GB. Not sure which versions.
Abrar, Ajid, Ansar. No one is giving answer. Okay, no problem. That is 256 MB.
Okay.
Okay, so automatic memory management is there for ASM instance or not? Tell me. Next question. Should I ask the question or should I finish the session?
And no, question is good. We should have.
Okay, thank you, Sunil. I'm asking for ASM instance. We had automatic memory management or not, or we need to configure that feature. Did you get my question, Srinivas? We have in ASM. Okay, another one. No automatic memory management. Okay. See, automatic memory management is enabled by default for ASM instance. Please remember, and will dynamically tune the sizes of the individual SGA memory component of ASM. So then the amount of memory that is needed for ASM instance will depend on the amount of disk space that is being managed by ASM. So remember that. And the second part of the ASM instance is the background process. So ASM instance can have many background processes, but not all are always present. So as we know that background processes basically help to the main process, and for ASM that are specific to do the task of ASM, basically because ASM instance share the same code base as an Oracle database instance. So all the required background processes of a database instance will exist in the ASM instance. So there are required background process and optional background process. So some are I'm telling. We had ARCN, so archiver process. This will exist only when the database is in archive log mode and automatic archiving is enabled. CKPT, checkpoint process, DBWN, the database writer process, DIAG, the diagnosability process, CJQ0, that is job coordinator process, which is started and stopped as needed by the Oracle scheduler dynamically spawn job queue slave processes, that is JNNN, to run the job. So LGWR log writer process, PMON process monitor, PSP0 the process spawner process, that is new in 12c, QMN and the Q monitor process. When you use AQ underscore TM underscore processes is 0, then this process will not start. And then SMON, everyone knows that. Then VKTM, virtual keeper of time process. Then MMAN, memory manager process. So these are the list basically, and there can be hundred of database instances, background processes running depending on the database option and configuration of the instance. So for ASM instance, these process will not always perform the same task as they would do in database instance. Suppose LGWR process in a database instance copies redo entries from the redo log buffer to the redo log files, right? And the ASM instance does not contain a log buffer in the SDA, so nor does it use online redo log file. So the LGWR process in an ASM instance basically copies logging information to an ASM disk group. Clear? So LGWR of ASM will do this thing. Okay. And if ASM is clustered, additional process which is related to cluster management will be tuning in the ASM instance, and that are LMON, LMDN, LMSN, LCKN. So LMON is basically global NQ service monitor process. LMDN is global NQ service daemon. LMSN is basically global cache service processes, and LCKN is basically a log process. Okay. And suppose when you are using ADVM volumes, means when you had ADVM volume configure, then we get VDBG. The process is called as volume driver background process. So what actually do? It will forward ASM request to log or unlock an extent for volume operation to the dynamic volume manager driver. So VDBG is a fatal background process, and termination of this process bring down the ASM instance. So another interview questions: which process will cause the ASM instance to bring down? That is VDG. Clear? And VBGN, volume background process, wait for request from the dynamic volume manager driver, which needs to be coordinated with the ASM instance. Suppose a request would be opening or closing an ASM volume file. When the dynamic volume manager driver receive and open for a volume, and due to a file system mount request, or close for an open volume, basically possible due to a file system unmount request, respectively. So that is unplanned death of any of these process does not have an effect on the ASM instance. So VBGN will not cause to ASM instance, but VDBG will cause a ASM instance to shut down. And VMB, volume membership background process, which coordinate cluster membership with the ASM instance. Clear? And this is ASM instance primary process, which mentioned here. So that is RBEL, that is used for rebalancing. ARBN, that process perform the rebalancing activity. Gmon is basically responsible for disk level activity like dropping and offline. And if you are advancing compatibility also. And mark basically mark the ASM allocation unit as stale. Suppose if any miss write happen for an offline disk, then on that time disk mark process will come into the picture. Then ONNN is represent one or more ASM slave process that basically form a pool of connection to the ASM instance for exchanging messages. So that ONNN will exchange the messages uh, in ASM instance. And PZ9N, that is a process which represent one or more parallel slave process that are used for fetching data when ASM is running in cluster configuration. Okay, or more than one matching concurrently. So you had $view from where you can get the information. Clear? So RBEL, ARBN, Gmon, Mark, ONNN, PZ9N. These are the primary processes. So remember each processes and each processes work. And if anything happen to these process, so what will happen to your ASM? Okay. So I hope you are on same page where I am.
Yes, Ahmad.
Okay, thank you.
Yes,
So
yes.
another ASM component is node listener. So basically this node listener is a process that help establishing network connection from ASM clients to the ASM instance. So the listener process is installed with the ASM software installation. It runs by default from the grid home bin directory, and the port number is 1521. The load listener is the same as a database listener or Oracle Net listener, because ASM is usually installed before installing the database. Okay, so the node listener is configured and started automatically to provide a gateway to the ASM instance for remote clients. Okay, so this listener is capable of listening for all instances on that machine, including database instances. So after ASM installation, a database can provide additional listener process and a set of configuration files. Then this node listener and separate database listener can run concurrently on a different port number, or the node listener can be replaced by separate database listener. So there are two configuration files for the listener process. So what are those? Listener.ora and sqlnet.ora. So which file is optional and which file is mandatory? Tell me. Question 9. Absolutely correct, Avinash. SQLNet.ora is optional, and the listener process is named is what is the name of listener process on the Linux platform? Can anyone tell me? TNSLSNR. Okay, it can be managed with the SRVCTL utility. So you can say that SRVCTL start listener hyphen n node name, SRVCTL stop listener hyphen n node name. So this is the way you can manage this listener, okay, with the help of SRVCTL. Clear? Any question till now? Any confusion?
Ahmad, question. If you have a listener on both the, say, database home and the grid home, which one you use? Use the ASM, like the grid home one, or?
See, database listener will come at the end, because first, if you had a RAC, first, if you started the clusterware, so grid soft clusterware is started. Then if you had ASM, so in that ASM basically started. So how disk information will be recognized. So that is the reason OLR come into the picture, Oracle local repository, that will tell about the disk related information. Okay, and after that your disk will be mounted. So it means your ASM instance will be mounted, and then your database instance will come into the picture. So in this way you can tell which one come first, which one come later.
You mean the grid part?
Basically, if we use grid, so then scan listener will come into the picture first.
Scan. Okay.
So every IP has listener. So if you are using 3 scan IP, so 3 scan listener will be available. And for connection, only one IP will be used. It means only one listener will be used. That listener is called as remote listener. So that scan listener will be configured through remote underscore listener, and local underscore listener will configure your database listener. Okay, so that scan listener will take the request, and it will search the least loaded instance. Okay, and that information will tell to that listener by the repository that name is missing this time, but I will tell you later on. And from that it will find out that okay, this instance A is least loaded. Then that instance listener, that is local listener, which communicate to the scan listener, and then the connection transfer to the local listener, and then client connect to the database through that instance. So this is the way your connection happens. Yep.
Yeah, thank you.
Welcome. Don't worry, network, I had one lecture specific, because in RAC network creates a problem too much. So there are many requests, I got it, or especially network related. So that's why I had prepared only one lesson. Which process help in communication between ASM instance and database instance? Okay, who will answer this? Question is that which process help in communication between ASM instance and database?
Node listener.
ASMB. One is saying ASMB, then I'm asking the process. Which process helps in communication between, excuse me, between ASM instance and that? One is saying ASMB. Is this correct? Okay, I will answer after finish my slide. Which one is correct? So ASM component, another component is configuration file. So as we know that when you install the software, cluster software or grid software, there are many configuration files that ASM include. Configuration file is SP file, which initiate the ASM instance and define startup parameter, and Aura PW plus ASM, which is the binary password file that is used for remote authentication to the ASM instance, and the load listener configuration files, which is a text file that define the node listener, and SQL node.data, which is an optional text file that provides additional listener options. Okay, and other text configuration files basically reside in etc Aura tab, which list all the instance which you have on that machine. So this is another interview question: from which file you get the information of all instances on your host machine? That answer is Aura tab. And Aura inst.log, which defines the Oracle inventory directory. Okay, clear? So most of the metadata that relates to ASM is stored within ASM disk group and in the memory base table of the ASM instance. Clear? So, but few other files are used for configuration. So the ASM instance uses two configuration files. The first one is the server parameter file that defines the initialization parameter at startup. That is a binary file that is created at installation by default in ASM disk group at plus disk group and cluster and ASM parameter file, that is the folder, and then a name is register.53.nnnnn like that. So the administrator may create a text initialization parameter file by default name init plus asm.aura, and the text and binary version are mutually exclusive for startup, and the other file that is used to configure the instance in the binary password file, that name is called as Aura PWD plus ASM, which I said this file is used for local and remote authentication from ASM client. So the password file can be found under the DBS directory. And the load listener also uses the configuration file. As I said, the first one is listener.aura, and the another one is spell.aura, spellnet.aura. Okay, clear? Which process, sorry, another component is group services. So then ASM disk group, then failure group, then ASM disk, then ASM file, then extend, then mirroring, and then client, then ASM utilities, then ASM privileges, then ASM OS group, then authentication, then ASM CMD command utility, and then password based authentication, then OS group, then separate, then ASM scalability. Oh my God, it's too much. Okay, so I'm stopping here. Okay. And then if I get a time tomorrow, then I will do that tomorrow. Otherwise, I will update you and you can connect. Okay. So from this, I will take on next lecture. And thank you so much for joining this ASM session. And it will take one more lecture for this ASM architecture. And then we go for machine creation that is practical.